and welcome to the Altinity Instructional Video Series. I'm John Hummel, Senior Technical Writer for Altinity. We're going to be continuing our series on using a Kubernetes operator to run a ClickHouse cluster. In our previous examples, we showed how to install the ClickHouse operator and go from a cluster with one node to hosting multiple replicas with multiple shards. One thing to note is we did not set up any persistent storage in all these examples. So any time that we stopped our cluster, or added new nodes to it, or any other configuration changes, all of our work was lost. Now, this might be fun, to have an interp set up all the data, and then change the cluster when they're almost done, just to hear their cries of torment. But that's a waste of time and resources, and there are better things to have interns do. Here's an example. We have the following configuration file that gives us 2 shards and 2 replicas. We set up a table in our ClickHouse cluster with replication. We can run select all from test and see the table. If we change our configuration file to just one cluster and one shard, then run kubectl to apply it, we're down to just one shard and one replica. If we run our select statement on our table again, and it's gone. Without persistent storage, we're kind of stuck in a world where all of our work goes away anytime the cluster changes. If you're hearing dogs in the background, by the way, that's my neighbor. He has about 100 dogs, give or take. We're going to build on our previous examples. If you need a refresher, go check out our other videos where we set up our cluster and replicas, or view our ClickHouse and Kubernetes guide on the Altinity documentation site, which includes code samples you can just copy and paste into your system. As a reminder for those coming from the other videos, we're running Kubernetes through the desktop Docker install on OS X, but the command should translate to your particular environment. We'll be relying mostly on kubectl commands with our friendly mascot, Cuddles the Cuttlefish. When we activate persistent storage, we move into the realm of templates. These take advantage of Kubernetes storage classes to determine how much storage is used, the kind of storage, and other settings. See the Kubernetes documentation for complete details. Create a new config file named sample5.yaml. We won't go over the entire file, but here's some important parts. Pod templates. This tells Kubernetes we're going to be using the ClickHouse Docker container. In our example, we're using the latest release of ClickHouse, but you can specify specific versions to meet your needs. Volume claim template. Here, we set up our storage type and a name. We're just going to give it 1 GB of storage. Not enough to be a real production system, but this is just meant to be a demo to get up and running. Everything else remains the same as our samples. Save it as sample05.yaml and run it with kubectl apply-f sample05.yaml-n test. Using our handy watch command, we can view when it's done. Watch kubectl-n test get chi-o wide. Neat. Let's test it. To test it out, we can exec into one of our pods. Use kubectl to show all the pods in our namespace test with kubectl get all-n test, and then exec into one of our pods to run the bash shell. When we run command df-h, we see the storage allocated. Ignore the overlay. What you really are looking for here is that we can see 995 megabytes have been allocated. Great. Let's connect to our cluster through the ClickHouse client, set up a database called test storage, and a table in it called teststorage.test. Create database test storage. Create table teststorage.test as system.1. And select all from teststorage.test. There's our table. Great. Let's prove our storage is consistent. We're going to change our configuration file, and the only thing that we're changing is going from 2 shards and replicas to just 1 of each. Save that as sample06.yaml and apply it with kubectl apply-f sample06.yaml -n test. Let's connect back to our ClickHouse cluster. Last time we did this, after a configuration change, our table went bye-bye. This time, select all from teststorage.test, and look at that. Our database and table are all there. There's a lot more configuration options that you can apply to your ClickHouse cluster running in Kubernetes. With the Kubernetes operator, you can set storage for log files, resource allocation, and other settings. Check out the ClickHouse operator GitHub page for an entire set of example configurations that you can apply. For a copy of this guide, see the Altinity documentation page. And to keep up to date with new events and webinars, visit our resources page. I know you already subscribed and rang the bell, because if you didn't, Cuddles the Cuttlefish would be sad. Thanks for watching, and until next time, happy coding.